Hello, brilliant minds. Over the past year and a half, we've talked about a ton of objects in our universe, from major planets like Earth and Jupiter, to wild moons, comets, asteroids, and everything in between. I've even dropped some snarky shorts arguing that since Earth doesn't completely clear its orbital path of every little rock and temporary visitor, we should either promote Pluto back to full planetary status or demote Earth to a dwarf planet too.
Why isn't Pluto a planet anymore, nerds? Well, the answer isn't because of its size or its mass, it's just because Pluto can't clear its orbit of the asteroids in the asteroid belt, which to me is kind of silly because if Earth was out there, we wouldn't be clearing our orbit either. Justice for Pluto.
That was mostly me being facetious and stirring the pot, but it gets at a real question people keep asking. What's the actual difference between a planet, a dwarf planet, a minor planet, comet, asteroid, meteoroid, meteor, and a meteorite? A quick note before we start. This video is informed by a long conversation I had with Daniel W.E. Green, a cometary scientist at Harvard who participated in the 2006 IAU General Assembly in Prague that reclassified Pluto. Some of the nuance that you will hear reflects ongoing debates within astronomy, not universally settled facts. Let's get into it. So planets, let's just start out with major planets. According to the IAU, a planet must meet 3 criteria. It orbits a star, it has enough gravity to be nearly spherical, and it has gravitationally dominated its orbital region, and that's the important one. Clearing the neighborhood doesn't mean removing every rock forever. It means the planet is dynamically dominant, something that can be quantified by comparing its mass to the total mass of other objects sharing its orbital zone. Earth qualifies by a wide margin. Jupiter seriously qualifies. We have one large natural satellite, the Moon, which is tidally locked and orbiting us, and nearly everything else in Earth's orbital region is either ejected, absorbed, or kept dynamically in check over time, often with significant help from Jupiter, which reshapes the inner solar system. So, now that we've got planets out of the way, let's talk about moons, or natural satellites. So a moon, which is more precisely called a natural satellite, is an object that orbits a planet. Earth has one natural satellite. We discovered it before we knew that any others existed, so it never needed a separate name. The moon is its name. Other planets have many, so we gave them names like Europa, Titan, and Phobos. Same category, one just didn't need the labeling competition for hundreds of years. So now let's get into dwarf planets. This is where it's going to start getting fun. A dwarf planet orbits the sun. It's massive enough to be nearly spherical, but it does not gravitationally dominate its orbital region. Pluto, Ceres, Eris, Haumea, and Makemake all fall into this category under this IAU definition. Pluto, for example, resides in a region beyond Neptune that contains many thousands of smaller planetary bodies with similar orbital and compositional characteristics. It is dynamically embedded among them rather than dominating the region. Pluto also lacks orbital dominance in another way. Its largest natural satellite, Charon, is unusually massive, about 12% of Pluto's mass. The two bodies orbit a shared barycenter that lies outside of Pluto's surface, which is very different from the planet-satellite system seen among the 8 major planets. So an important nuance here. The term dwarf planet was introduced in the IAU in the early 2000s as part of an effort to formalize planetary classifications. Crucially, the IAU resolution explicitly states that dwarf planets are not major planets, a point that remains controversial among astronomers. Dan Green, for example, voted against this aspect of the resolution. He and others argued for retaining the long-standing distinction between major planets and minor planets, with large trans-Neptunian objects treated as a subset of the latter, just minor planets. In other words, the dwarf category was a compromise, not a naturally discovered class. So, after major planets and dwarf planets, we have minor planets. And yes, dwarf planets are just the largest minor planets. Again, this category was more of a political PR kind of compromise than anything else. Most real cometary scientists have actually seen Pluto as closer to a comet than a planet, okay? So, like I said, minor planets is an umbrella term for solar system bodies that orbit the sun, are not classified as major planets. This includes most objects historically called asteroids and many distant icy bodies beyond Neptune. Minor planets span a wide range of sizes, shapes, and compositions. Some are irregular, some are nearly spherical. Shape alone does not define this category. Many of the objects may have formed directly from the primordial solar nebula rather than as fragments of larger worlds. Now we get into asteroids and comets, which are, again, minor planets. So if you forget any of this and you find yourself stuck in a conversation, you can refer to anything that's not one of the 8 major planets as a minor planet, just to help you out. Traditionally, asteroids refer to rocky or metallic minor planets located primarily in the main asteroid belt between Mars and Jupiter. Objects in resonant or planet-crossing orbits like Jupiter Trojans and objects beyond Neptune are more accurately described simply as minor planets, not asteroids. Comets, on the other hand, are icy bodies that develop glowing comas and tails when heated by the sun. Some interstellar objects like 2I Borisov clearly behaved like comets. Others, like 1I Oumuamua, showed no obvious comet or tail, and their composition remains uncertain. Same rough size range, very different behavior. And also, asteroid cream would have been a way better name than hemorrhoid cream. I'm standing by that. So now we get into meteoroids, meteors, and meteorites. This part is all about location, not composition. A meteoroid is a small object in space. A meteor is the streak of light when it burns up in Earth's atmosphere, and the meteorite is the piece that survives and hits the ground. There is no magical size where physics changes, okay? This is just a bookkeeping line where human convenience picks in. So let's look at the big picture of all of this. Most astronomical categories are filing systems. They're not laws of nature. Pluto didn't change in 2006. Ceres didn't change in 1801. The solar system didn't get a memo from the universe. As the International Comet Quarterly article, "Is Pluto Just a Giant Comet?" points out, the real mistake is pretending that statements like "there are 8 planets" have any sort of deep physical meaning. They don't. And that's a good thing, because science isn't about preserving tidy lists. It's about refining our models when reality refuses to cooperate. Thank you so much for watching. Make sure to let me know what you think down below and share this with a friend who thinks Pluto is still a planet. Thank you for learning with me and have a wonderful day.